territory. And actually, most of what is the rest of the year is uncharted territory, but this happens to be the hardest of the topics. So what we're doing is high degree polynomials. High degree polynomials. All right. I am going to have us actually get out your calculator and switch to graph mode, and just have that ready. I won't be able to display because I'm just not going to get up and connect my calculator up on the screen, but we're going to see several principles. Now, we need to be able to classify polynomials first. So let's talk about that. That's actually not too bad. We need to be able to classify them by term number and degree. Now, when I say degree, I don't mean degree as in an angle. So the degree of a polynomial is going to be the highest exponent. And actually, I'm going to put exponents. So let's do a few examples of degree. So if I have 4x plus 5x squared minus 2 plus 8x cubed. Okay? Now that polynomial is vastly out of order, and you're going to want to get in the habit of putting them in order. So let's just get that in order. We put it in order of highest degree, highest exponent. So the x cubed thing is going to go first. All right, so what is the degree of this polynomial? Well, it's 3. Okay, so it's the degree 3. Well, how do I know? Well, because the highest power is a 3. Does that make sense? Okay, now each of these numbers are coefficients. So 8, 5, and 4 are coefficients. This 2, this negative 2, is a constant term. So we're going to want to be able to identify that as well. All right, let's get another example. Maybe I have 8 plus 3x squared y to the 5th plus 4xy minus 7x to the 6th. Now, on this one, I'm not going to bother putting in order because we have multiple variables. But I am going to talk about degree. So, I look at this term. Now, the degree of this term is 0. Why? Because the exponent on the variable is 0. There is no variable. Now, on this term, I see an x squared and a y to the 5th. So when I have multiple variables, I'm just going to add their exponents, and I need to get a degree of 7 on that term. Okay, 2 plus 5, 7. And then on this term, I see an x and a y. And the power on both of those is a 1, so the degree of that term is a 2. And then, of course, we do have our last term here. So we have x to the 6th, that's just 6. So what's the degree of this polynomial? Well, this is the highest one. So the degree of this whole polynomial is 7, because that's the highest. Okay, now we can classify them by term number. If I have one term, that's a monomial, meaning mono meaning 1. And if I have two terms, now after I simplify, that's important. If you can simplify, you need to. If I have two terms, that's a binomial. Bi meaning 2. Okay, 3 terms. That's a trinomial. Tri meaning 3. Now anything more than that, while we could have quad and I don't know if we even say pentanomial, but anything higher, 4 or up, we're just going to call polynomial. That'll just be our thing, polynomial. Poly meaning many. We have lots of terms. Now, technically, all of these are polynomials.
Attention students and staff. The pie in the face will take place today at 2:30 in the gym. Again, the pie in the face.
Okay, 2:30 gym, we got it. All right, so let's classify these. That'll be one example, and this will be the next example. And one more example. Okay, so as I'm classifying, I'm going to want to get things in order. So I only have one variable. So on this one, I put the highest power first, and then I descend down. Now, if it's not written, it's a plus, so that's a plus 3x cubed minus x. And I see that I have three terms. That means this is a trinomial. And I also see that my highest power is a 4. So my degree is 4. Now this degree is actually going to be very important for what we are going to do, as you're going to see shortly. It's actually probably the most important thing about classifying.
Wait, where did you get your name?
There's three terms.
Oh, okay.
1, 2, 3. Jesus loves me. 3 and 4, he loves me more than you. No, I'm kidding, I'm kidding. All right, so we put this one in order. So it's going to be negative 4x to the 5th, plus 2x squared, and then plus 10. I'll say that's a 10, I don't know what is it. And then plus 3. Now these I can combine, so I'll go ahead and combine them. I always want to simplify before I do this. So then I have negative 4x to the 5th, plus 2x squared, plus 13. So that's going to make this a trinomial. And its degree is going to be, what do you think? What's the degree of this?
5.
5. Okay, because the highest exponent is a 5. And again, that degree is going to be very important for what we are doing. If you can, once you get these in order, looking at that first term, actually, and this is something that we can say with much confidence. For what we're doing, this first term is the most important thing. Everything else, not quite as important. This first term tells us almost everything that we need to know for what we need in this chapter. All right, the last one, we're going to put it in order. I'm going to go ahead and combine as I do it. So I see that this negative 6x squared and this 10x squared are alike. So I'll combine those. So I get x to the 4th, that's going to be my first term. And then I don't have any x cubes. So now I have x squared, so minus 6 plus 10, that's going to be 4x squared. And then nothing like this 4x, so plus 4x. And then I have a minus 12 out here. So this is not a trinomial. I have 4 terms, so this is a poly. I combined it. This plus this, so negative 6 plus 10 is 4. So I got 4x squared. So this is a polynomial. So it has 4 terms. And the degree is 4. Why? Because my highest power of x is 4. Any questions on classification or simplifying these?
Can this be it?
Nope. But the next thing actually isn't too bad. I mean, we aren't hitting the part where we start pulling our hair out and becoming bald. That's tomorrow. But
I'm going to be sick tomorrow.
it'll be here waiting for you.
Oh.
Okay, so what we're going to do now is we are going to determine the end behavior. End behavior. End behavior. So this is where we're going to want our graphing calculators for. Now it's true, on each of these, you could graph them. Now, some of them are designed such that it's really a pain to actually see the end behavior because they give you really strange things to happen. But you could graph them and answer the question, the end behavior. Well, what do I mean by the end behavior? Let's say I graph something. So this is just going to be a rough sketch. And on this rough sketch, I'm going to identify everything that we are going to be doing for this chapter, actually. And then we'll talk about the end behavior. So let's say I get a graph, and it comes out something like this. Okay? Alright, so I'm going to just highlight these points. I'll highlight these points and this point right here. Okay? And actually everything that I have put a dot on is something that is going to be important for this chapter. So let's go ahead and name each of those things. First of all, so I'll do in red, the zeros. And actually from the last chapter we actually know what a zero is. This is an x-intercept. And it happens when the graph crosses the x-axis. So I see zeros right here. That's a zero. And this is a zero. Now a zero also has another name. It's also called a root. Okay, so x-intercept, zero, root, all referring to the same thing. So the directions could say to find either one of those, and you're going to be doing the same algorithm, the same set of directions that I tell you. All right, in black is going to be our extrema. You can think of extrema as the humps. And what these really are areas, these are the highs and lows. And you can find, this is what you have to have your graphing calculator for. When you're in calculus in college, you will do it with an algebraic method. But for now, what you're going to do is use your calculator to find these. But you should know where they are. Do you understand that that's a high point? So we would call this a max, a relative max. And this one over here, you just see how it comes up and then comes down. It's a hump. That is also a relative max. So we see that we have two of them. And right here at the bottom, this is a relative minimum, because it's at the bottom. So this basically encompasses what we are doing for this chapter. Finding all these things. All right, well, I haven't even talked about end behavior. The end behavior are the tail ends. And what we're asking really is what happens as x goes to negative infinity, meaning gets really, really small, and as x goes to infinity, as it gets really big. Alright, so my tail ends tell me that. And on both ends I see it's going down, right? It goes infinitely down. But for us, what we're concerned for is, are they up or are they down? And in this example, my tail ends are down, down. And I get that just from the picture. This end is down and this end is down. So down, down. That's my end behavior. Down, down. So we'll do the left arrow meaning the left tail end and the right arrow meaning the right tail end. Now you could say down, down, or you could write up, up. But we'll do the first thing you write, I'm going to consider being the left tail end, and the second thing you write meaning the right tail end. Okay, so we got that from the picture, and we can get all of these from a picture. So I have another sketch? Let's do one more sketch. Okay, just want to be consistent in my colors. Okay, so let's point out our main things. So this is a what? Relative max, and this is a what? Okay, whatever they happen to be, those are the relative extrema. Okay, each of these where I'm putting a red dot, what are those? Zeros or x-intercepts or roots. Okay. Now, let's talk about the end behavior. Well, the first tail end is down, and the second tail end is up. Any questions on that?
Is that all you do?
Yes, that's it. But you need to be able to do it without a picture. So, let's do one without a picture. No, how can I get this without a picture? So let's say we have y equals 5x cubed plus 2x squared minus 8x plus 20. So we're going to do this without graphing. Luckily, it really isn't that bad. Because all that matters, just like I told you a few slides ago, all this extra stuff doesn't matter. Once I get everything written in the correct order, highest degree first, all that really matters is this term. That will tell me everything I need to know. So, here are our basic principles. If my degree is odd, then my tail ends are down and then up. Okay? If the degree is even, then, now you might think from the example I gave you, down, down. Nope. If it's even, it's up, then up. All the time. But wait a minute, Mr. Kane. On your example in your drawing, you had going down. 2 downs. Well, how does that happen? Well, that's where there's one more thing that we need to know. So that's how it starts out. So I look at this and I say, oh, it's cubed. That's odd. My tail ends are down and then up. But I need to consider the coefficient. Okay? If the coefficient is negative, flip. Okay, because that tells me I have a reflection over the x-axis. Which means, well, basically over the x-axis, it flips upside down. So if this were negative, then instead of being down up, it's going to be up down. Alright, so what would be the answer to this question, end behavior? In this case, the end behavior for this, without even graphing it, I know it's going to be up down. That's the answer. Alright. Well, let's do a bunch of examples and see if we can figure out some things. So y equals negative 7x cubed plus 8x squared plus x. And then y equals, let's say, 1 minus 4x minus 6x cubed minus 15x to the 6th. Then y equals negative 5x to the 5th minus 15x to the 7th minus 4x to the 9th. And you see you're getting high powers here. These really are designed that you can't just graph it, that you have to look at the polynomial and know based upon the information I just gave you.
So was the previous answer up, down?
Up, down.
But
yes.
it
If
wasn't
this,
negative.
if this is negative, then I flip it around. Oh wait, Am I dumb? I'm dumb. Yes. The answer was down, up. Thank you. It should have been normal. I flipped it even though it wasn't negative. I shouldn't have flipped it. It's down, up. Because, no, I just messed this up. Here's a table of how this goes. Okay? Degree. If it's odd, if it's even. If it's odd, down, up. If it's even, up, up. That's if my coefficient is positive. If my coefficient is negative, these flip. So what I did, I made an error here. I was talking about the coefficient being negative, and then I flipped my answer around. It should not have been flipped around. It should have been down, up. If my coefficient is negative, then these switch. And this is odd, so this is down, down. Thanks for saying something, Caroline, because that would have been bad. It's really bad.
Positive on
So, well, we'll go through and practice this. But that basically is the table that tells me my end behavior. And this always works. There is not an exception to this. All right, so let's take a look. We need to look at our highest power. So that's this one. So I see my power is odd. So that means I start at down, up. But my coefficient is negative, so these flip. So since they flip, I have up, down. Boom. That is the legit answer. Now this next one is out of order. I do need it in order and simplify. So this is the highest, and really, all that matters is that one with the highest exponent. The rest of them are not going to matter as far as the answer to the question. So this is an even power. So I start at up, up. But my coefficient is negative, so I flip. And it's going to be, instead of up, up, it's going to be down, down. And that is my final answer. All I look at is that highest power. That's the only term that matters. All the rest of the terms, do determine stuff, but not the end behavior. Only the first term is going to determine the end behavior. And actually the first term determines something else that we're going to talk about in a minute.
Why is that up 15 is not?
No, it's saying that normally it would be, if 15 was a positive, it would be up, up. But since it's negative, you do down, down.
Yep. If my coefficient is negative, it switches from what it would be to both the ends flip their direction. So when I have an odd, my tail ends start like this. But if my coefficient, the number in front, is negative, then they flip direction.
No.
It's a negative 15.
It's a degree. It's talking about the degree. The degree is even. 6 is an even number.
The degree is even. That's what makes it up, up. This being negative is what flips it around. So the coefficient is the number in front. The degree is the exponent.
So you're looking at the degree.
Yeah. Okay.
So when I determine that it's up, up, I look at the 6. All right, so the next one. I need to get this in order, so it's negative 15 x to the 7. Oh, nope. Negative 4 x to the 9. Didn't see that 9 there. So I get this in order. So to determine the direction, I look at my exponent, and that is odd, so it tells me I start at down, up, because it's odd. Now I look at my coefficient, that's the number in front, and I see that it's negative. Since it's negative, flip. So it's up, down. All right, this one's in order already. My coefficient is positive. It's an even number, is what I meant, it's even. So where did my tail end start? Up, up. Okay. My coefficient is a 1, so it's positive, so it stays up. Any questions on that? Okay. No, we aren't quite done yet. You with me so far? I know it's a lot, but each of the little pieces so far aren't so bad, right? All right. Now we're going to start to want a helmet, so get your helmets ready. Here we go. All right, so I told you that that first thing also determines something else. So let's say I have this. Again, all that really is going to matter is that first term. All the rest, not going to matter for what we're doing yet. So this is what I look at. So from our tail ends, my tail ends are up, up. Any questions on that? The next question I might ask is, how many zeros and extrema are there? Now, we can't answer that exact at this point, but we know how many zeros are possible. And the number of zeros possible, there are 4 possible. Well, how do I get that? My degree is 4, which means it could cross the x-axis up to 4 times. So let's take a look at how that could be. A degree 4 could look like something like this. Okay? That could be a degree 4. So take a look at how I know. So I'm going to copy that. Paste it. Okay? So I don't know where it is, but look. Zeros are where it crosses the x-axis. It crosses how many times? Right there. It could be right there, so how many times? Once, right? Now how many times does it cross? 2. And now how many times? 3. Now how many times? Okay, now how many times? Nope. 3. Now how many times? Okay, and of course it could be up here, and then how many times? How many times does it cross the x-axis? How many? 0. 0 times. Once, twice, 3, 4, 3 again, 2. Okay, well what's my range? 0 to 4, right? So 4 are possible. Extrema, 3 possible. There's 3 possible extrema. It doesn't mean that I have 3, but up to 3 are possible. Well, how did I get that? I just looked at this. 4 possible zeros. 1 less than that, possible roots. So it is going to be a lot to remember. What if I had this? Without graphing it, okay, my tail ends are what? What are my tail ends?
Going to be down, down.
Down, down. My tail ends are down, down. All right, how many zeros?
2.
You said what?
2.
Up to 2, right? And how many extrema?
1.
Up to 1. Okay, it's 1 less than the number of zeros. You can't have more extrema than you have zeros. Now, I could have only 1 0. I could have 0 zeros. Okay, but the max I'm going to get is 2. Okay, and the extrema 1.
Wait. Oh, okay. That's 1.
That's supposed to be a 1.
Don't you flip those tail ends because it goes in?
Well, an even exponent tells me start with up, up. But because my number in front is negative, it flips around to down, down. Okay, are you ready to do a few practices of that? Just telling me how many zeros and how many extrema there are? I'll say that you are. And I'll just leave these in order. All right, so just like with the tail ends, and we'll practice tail ends too. I only care about this first term. All right, so tell me about the tail ends.
Goes down, up.
Down, up. Okay? So we're describing the end behavior of the graph when we do that, talking about the tail ends. I might just say, tell me the behavior, and then you're going to answer all the other questions. So the zeros. I have up to, how many? 3. It's just that exponent. And if I want to talk about the extrema, the maxes and mins, I have up to, how many? 2. Just one less than that. Okay? Why is that the case? Because this has to be a degree 4. Because if I were to draw it, that's how many times it could cross the x-axis. It's the same as the exponent. All right, how about this one? The tail ends are what? They are both up, up. Okay, the zeros are what?
6. Up to 6.
Yep. And the extrema? Up to 5. I'm using that to be less than or equal to. All right. How about the tail ends on the next one?
Up, down.
Yes, up, down. We had to flip them around because of the negative coefficient. The zeros?
3.
Yep, up to 3. And the extrema? Up to 2. So the last one, tell me about the tail ends. Nope. Yes. Down, up. Good job. Yes. The 4 was making me think up, up, but no. I look at the degree, right?
Too. Okay, I'm not the only one.
You are not the. That's actually what makes this chapter really tricky. Is you get all this stuff, but then like, it's a lot. It is a lot. So you have to, whatever you need to do to remember that, do that thing. All right. The zeros we have up to 5, right? And the extrema is 4. Okay? Now, the next example I'm going to put on a graph, but you're actually going to have to use your calculator to help you do what we're going to do. So, here's my graph. So you can copy this if you want, because I am going to be a little bit more purposeful about it. Okay, so the graph right here. Okay. This is what you'll need your calculator for. So you actually put the formula in your calculator. And this is going to be calculator work for the most part. We are going to want to know where these are. Well, what are these that I'm circling? The maxes and mins. We are going to need to know those. For now, I'm just going to tell you what they are. So this is negative 3, 3. This one is 3, 2. And this one is 0, negative 4. Okay? You will get those from your calculator. Just for speed, I am telling them to you. All right, what we're going to do is we're going to do the intervals of increasing and decreasing. Okay? Well, increasing and decreasing is actually just like the rest of today is pretty simple. Increasing is where it's going up. And decreasing is when it's going, what do you think? Down. So, but it's figuring that out that is tricky, and you need your calculator to figure this out. So what I'd encourage you to do is when you are asked to find the intervals of increasing or decreasing, graph it on your calculator, get it so you can see everything. Then do a rough sketch. You don't have to graph it perfect on your paper, but do a rough sketch of what it looks like on your paper. Then go back and on your calculator, find all these points. Okay? And I'm going to show you how to do that in a moment. Okay, so we're going to say we used our calculator and we found these points. So where is it increasing? Do you see from here to here it's going which way? Up. So I'm going to say from, now I don't include infinity, but from negative infinity to, now the question is what do I put here? I look at x values. So to negative 3, I am increasing. Okay? But then starting at negative 3, what happens? I start going down. Okay? So from negative 3 to where does it stop going down? 0. When x, no, don't get confused. The y value doesn't really matter right here. It's the x value. So starting at 0, it stops, right? So from negative infinity, from negative 3 to 0, it's decreasing. Then from 0 to 3, what's happening? From 0 to 3, it's doing what? Increasing. And then finally, what's the last piece? From 3 to infinity, what's it doing? It's decreasing. Oh boy, we are out of time. All right, I'm going to save this.